Section 5.4 Polynomial and Rational Inequalities. We want to solve for inequality greater than or equal to 0 by graphing the order of x equal x minus 1 divided by x squared minus 4. Order of x is the example number 1 in section 5.4. We already graphed this rational function. So from this rational function, we assign the function notation for this. On the left-hand side, that is order of x. On the right-hand side, that is g of x. If you wrap order of x and g of x together, order of x will be the blue curve, and g of x is the x-axis, y equal to 0. So order of x greater than g of x, we were looking for the pieces that above the y equal 0 line. So we look at these pieces. It is above the x-axis. So that would be the answer for this problem. The two pieces, the two yellow pieces, they are the answer. The answer for this problem is from -2 to 1 and union 2 to infinity. Because the domain for this problem is that we exclude the +2 and -2. So we use the parentheses at 2 and -2. And we include the one with the bracket because in the inequality we have the equal sign. So the idea to do this problem is that we pay attention to the special points. First of all, we have this point. This point is the vertical asymptote. The two pink points, they are the vertical asymptote. And the red point is the x-intercept. So what all we need to do is find the vertical asymptote and the x-intercept. We will put them on the x-axis, and then we will test in the point. If it gives you positive, then the graph will be above the x-axis. If it gives you negative when you test in the point, the graph will be below. So depend on the problem, we will choose the pieces below or above. We will use that idea to solve the inequality using algebra, not graphing. And it will simplify us a lot of work because you know that we graph the rational function, it takes a lot of time. In example number 2, we will solve this inequality using algebra. And it will be easier if we have one side 0 instead of the 3. So I need to rewrite this inequality so that I will have 0 on one side. I will -3 for both sides. And then I need to combine the left-hand side to become a rational fraction. So we will find the least common denominator. The least common denominator for this problem is x minus 2 squared and x minus 2 squared. So we have the same denominator, x minus 2 squared. Then we will subtract the top. The parentheses we will expand, so we get x squared minus 4x plus 4. And then we will combine like terms. We will open parentheses and combine like terms. So we simplify the top. We will cancel the 3x squared and the 3x squared. For the x term, we will The problem is x plus 2, not x minus 2. So when we expand this, that will be x squared plus 4x plus 4. When we distribute the 3, so we will have everything minus. And to simplify the x, we will get 1x minus 3. So we're going to draw the number line. You notice that on the top, it will give you the x-intercept. The x-intercept is 3, and the bottom one will give you the asymptote. So x minus 2 equal to 0, so x equal to 2. So 1 is the asymptote, which is 2, and 1 is the x-intercept, which is 3. You notice that the asymptote is the line that the graph will never touch, so later on we have to make the parenthesis or open circle at 2. Now we will test the points in the interval. The point will tell us that the graph is above or below the x-axis. So right here, I will test 4. Right here, I will test 2.5, and I will test negative 3. What all you need to do is input the 4 into the x minus 3 divided by x minus 2 square. So 4 minus 3 and then 4 minus 2 square. What do you want is less than or equal to 0. So we'll see what is happen. It's true or false. So we get 1 on the top. In the bottom is 4. 1 over 4 less than 0. This is false. Now you test 2.5. 2.5 minus 3 and then 2.5 minus 2 square less than or equal to 0. 2.5 minus 3 is negative 0.5. 2.5 minus 2 square, you get 0.25. This answer is a true answer because when you divide a negative number to a positive number, you will get the answer negative. So this statement is a true statement. And then when you check negative 3, you will get the answer is negative 6 less than or equal to 0. So negative 6 less than or equal to 0, that is a negative number, and this is a true statement. We are looking for the negative number because in the statement they are less than 0. So we're looking for the true one. So we will take this interval and we will take this interval. The answer for this will be negative infinity, 2 union 2, 3. The reason why we have parentheses at 2 because 2 is in the denominator. That is the domain we need to exclude, and that is the x-intercept. The reason why we have 3 brackets is because there's equal sign in the problem.